Introduction. In this chapter, the degradation of the battery is developed. The main consequence is the loss of energy storage, which is very important because it establishes the autonomy of the vehicle and can condition the provision of the service due to not having the required autonomy, requiring change for a new battery or the acquisition of a new vehicle with the high cost that entails. Index. Consequences of battery degradation. Symptoms of degradation. Formation of dendrites. Reason for degradation. Factors of battery degradation. Degradation at rest. Tips for good parking. Real cases Tesla. Real cases recurrent auto study. Tips to extend battery life. Subscribe to the Fleet Management channel. Your subscription is a great support to continue making new videos. Subscribe. 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 Degradation at rest. Electric car batteries can break down and even become unusable if they spend a long time without plugging in periods of several months. If not recharged frequently, the high voltage battery of an electric vehicle can suffer irreversible damage. These damages are a consequence of the gradual decrease in voltage in the battery cells, a process called self-discharge. Above a certain minimum threshold, which is around 2.5 volts, although it depends on the type of cells, the discharge is so intense that the cathode of the cells suffers alterations in its composition, which will make it impossible to recharge them again. In practice, this deterioration occurs in all the battery cells simultaneously, making the battery pack unusable. An electric car loses about 1% of battery charge every week. At this rate, a fully charged battery that remained parked would take 2 years to approach the area where it could begin to deteriorate. But there are aspects that can accelerate this discharge. Aspects that affect battery discharge. The temperature. Excess temperature deteriorates by itself, and apart from the discharge, the chemistry of the cells. In this way, it is not at all advisable to park an electric car at high temperatures, for example, with peaks of more than 40 ABC, because the battery will suffer a lot and will self-discharge a little faster. Load level. Self-discharge is a little faster when the battery is 100% charged. Additionally, a fully charged battery ages faster than one with a medium charge level. For this reason, most manufacturers recommend that, for prolonged periods of inactivity, the battery must be left with a charge level of between 50% and 80%. Maintenance tasks that the vehicle will carry out while it is parked. These are automatic processes that we are not aware of, which vary from one manufacturer to another and which can translate into relevant energy consumption, at least from the perspective of leaving the car stationary for several months. An example of consumption is what all Tesla models have when they are parked, especially if functions such as Sentinel mode are left activated, which monitors what is happening around the car and even records if it detects strange activity nearby. When we park a Tesla, get out and walk away, the car turns off and locks automatically, and we may think that it is completely disconnected. But some of the car's functions are still running. Therefore, when we approach again, and simply carrying our cell phone in our pocket, the car is prepared to detect us and open the doors. Then, when we get behind the wheel and press the brake, the user interface screen will start up instantly without any delay, as if it had never been turned off, and it has never really gone out. The consumption of a Tesla with Sentinel mode is around 3% daily. Obviously, that can translate into a complete battery drain in less than a month. Even disconnecting the Sentinel mode, Teslas have higher consumption than the average model. Fortunately, when the battery charge drops to around 5%, a Tesla activates its deep sleep mode and stops consuming power. This protects the battery during storage, although in return it deactivates all comfort and connectivity functions. Almost all other electric models also present consumption that will gradually reduce the battery charge and to a greater extent than the self-discharge of the cells themselves. For example, all electric vehicles equipped with telematics services have to keep their communication module powered continuously, and it is a device that is connected to the 12-volt battery To avoid complete discharge, the car will periodically check the voltage of the low voltage battery, and if it drops too low, it will activate the high voltage battery to keep it charged. Another source of consumption is the battery's own air conditioning. Some manufacturers, such as Smart, keep the car battery heated while it is parked. If the car is inside a garage, there will be no problem. But if we leave it parked outside and under extreme cold or heat conditions, the car will use energy from the battery to control the temperature of the garage itself, and that will significantly accelerate the download rate.
Learn about our fleet management consulting and training services. Reduce costs and optimize fleet management activities. We electrify your fleet of vehicles. We carry out the electrification plan until its implementation, known as
Tips for good parking. Park the vehicle in a covered garage with a controlled and stable temperature and always below 30 degrees Celsius. Almost all garages are quiet, dark places with a constant temperature of around 23 degrees Celsius, so they are ideal places to park an electric vehicle. Leave the vehicle with a state of charge of around 80%, which represents a good compromise between charge level and maximum storage time. Of course, and if the vehicle has a programmable pre-air conditioning system that can be activated without the car being plugged in, make sure that no programming is active. Use the vehicle's telematic services. If the location chosen for parking has coverage, you can use the car's telematic services to check the rate at which the battery charge is decreasing after a couple of weeks. Without changes in storage conditions, this rate should not be altered during the remainder of storage. Leave the vehicle plugged in. In the worst case scenario, and if you want complete peace of mind, remember that you can always leave your car plugged in, and in the most modern models, with the charge limited to 80% or 60%. In this way, the system will maintain the battery charge at a constant level for the entire duration of the storage. Real case is Tesla. The study carried out by Tesla on its entire fleet of Model S and X is developed below, which has already traveled several 100,000 kilometers. To provide information on the degradation of its batteries, the result is a specific figure of the loss of capacity of its batteries over time that can be considered very close to reality. The study has been published in Tesla's so-called 2022 Impact Report. According to the company, they have been working hard to extract this specific data. The study has been carried out on the Model X and Model S platform. The Tesla Model X and Model S, with which this test has been carried out, were equipped with NCA, nickel, cobalt, aluminum batteries with cylindrical cell format 1865 supplied by Panasonic. Tesla has stated in its report that after a trip of 322,000 kilometers, its battery has only registered 12% degradation compared to its factory levels. On average, the Model S and Model X lose 1% of capacity every 26,816 kilometers traveled. That is approximately 6 kilometers of autonomy. Real Cases Recurrent Auto Study. The study published by Recurrent Auto on the degradation of the battery of an electric vehicle is developed below. The report analyzes some electric vehicles launched years ago, that is, models belonging to the first generations, which is why they have a higher mileage, reviewing a total of 15,000 different electric vehicles. However, the study points out that electric models still do not have a long enough lifespan to know exactly how long a battery can last in an optimal situation. Only 1.5% of vehicles have required a battery change, not counting cars scrapped or completely scrapped due to external factors such as accidents. Few vehicles have needed replacement even after the end of the warranty period, which is usually 8 years or 160,000 kilometers. Some brands more and other brands less. Most manufacturers suggest that batteries should last around 20 years. So far, few electric vehicles are that old, so it's not really something that is known for sure. Two cars mainly stand out in the study, the Chevrolet Bolt EV and the Hyundai Kona Electric. However, this has an explanation. Both brands were forced to carry out a major recall of many of their vehicles due to a failure in the battery system. something that was solved after this massive replacement. After these two specific cases, the list includes the Nissan Leaf and the Tesla Model S. The first of them is one of the oldest in the segment. In fact, those who suffer the most from battery replacement are those registered in 2011, that is, more than 12 years of life history. In any case, only 8.3% of Leafs sold have needed a battery change, or in other words, 91.7% have not needed it. In the Tesla Model S, there is a similar case, since those that have suffered the most from this replacement are those marketed in 2013, and we are only talking about 8.5% of those registered. Real cases recurrent auto study. Battery degradation. The graphs show the degradation suffered by batteries according to their capacity. The Nissan Leaf is one of those that best maintains initial autonomy, even after exceeding 160,000 kilometers. On the contrary, one of the most pronounced degradations is presented by the Tesla Model S with the 100 kilowatt-hours capacity battery, which noticeably decreases its performance shortly after starting its work. In fact, this is the version of the Model S that loses the most autonomy percentage-wise over time, according to the study. Real cases recurrent auto study. The Ford Mustang, Mach-E or the Hyundai Ioniq 5 do not yet have such an extensive life history to be able to analyze their degradation effectively. Both vehicles, after more than 100,000 kilometers on their odometer, more than comply and maintain a fairly correct autonomy. Tips to extend battery life. Below are the main measures to take so that the battery does not degrade and lose capacity over time. The more discharges and recharges, the shorter the battery life. It is recommended to carry out the smallest possible charge-discharge cycles. If possible, recharge the battery when it is close to 20%, up to 80%. Use smart charging. Recharging is managed by the vehicle's BMS or external software, which controls the balance of the cells, temperature, voltage, intensity, etc. of the battery. Intelligent recharging manages the amount of energy and power supplied to the battery so that it degrades as little as possible. Avoid high and low temperatures. High and low temperatures must be avoided when parked, because normally the battery cooling system is not in operation. It is best to park the vehicle in a covered parking lot with a constant temperature if possible. When the vehicle is on, the cooling system is running managed by the battery BMS. Currently, all electric vehicles have liquid cooling. The coolant must be changed when recommended by the vehicle manufacturer so that the battery operates in the appropriate temperature range. Do not recharge the battery to 100%. A high state of charge close to 100% degrades the battery. It is recommended that the state of charge be between 20–80% of its capacity. Tips to extend battery life. Do not consume all the battery power. Too low states of charge harm the batteries because the internal components suffer greater stress. It is recommended to use up to 20% of the battery charge. Do not perform quick recharge. Fast charging degrades the battery more quickly than standard charging, so it is recommended to use it only when strictly necessary. It is recommended to use the slowest recharge possible. Avoid continuous fast downloads. Discharging a battery too quickly also leads to early battery degradation. Continuous strong acceleration degrades the battery, so it is recommended to drive efficiently and provide training to drivers. Other aspects to take into account. It is exposing the batteries in environments that are too humid, avoiding physical and mechanical damage, such as sudden blows or punctures.